Hi, my name is Jared, and along with Natalie, Jeremy, and Jason, we are FTM. In this video, we'll show you our journey of creating our Engineering 112 design project, the Adapted Bass Drum.
Our group was given the task of working with the Arc of Harrisonburg in order to create a bass drum that accommodates the needs of one of their residents. The Arc is a facility which promotes the rights of people with intellectual or developmental disabilities and works to get them involved in the community. Because those kinds of disabilities often manifest in physical ways that interfere with the conventional methods of playing drums, we set out to create a bass drum which can be played in an alternative way.
Our brainstorming yielded 3 concepts for designs that would provide our clients an alternative way to play the bass drum. Our first design was a bass pedal, which had an attachment that allowed the client to control the orientation of the strike. However, it was determined that this design was too hard to produce and didn't address as many clients as we wanted. Our second design was a vertical pulley, which allowed the client to create 1 drum strike per pull. We canceled that idea because it was too strenuous for some clients, and it placed a limit on how fast the client could play the drum. Our final design was a rotating hand crank, which allows the client to create strikes purely by rotating a handle.
Our final design uses a combination of a rotating hand crank and the elasticity of a rubber band to strike the drum. When the handle is rotated, a downward force will be placed onto the striking piece, which would be pushed against the rubber band that, upon release, would forcibly push the striking piece into the drum. We agreed that we wanted our creation to be purely mechanical and entirely handmade, so our first step was to plan a trip to Home Depot. At Home Depot, we browsed the wood section and picked out our first batch of wood that would eventually become our first prototype.
Over the next few weeks, several more trips were made as we pieced together our final design in the wood shop.
Closes in what?
Like, they zoom in closer.
Oh, I think it's just your phone. You don't do that.
Unfortunately, the majority of the wood we worked with was severely warped.
603 centimeters.
Consequently, most of our measurements were no longer represented an accurate guide to the placement of holes. We resolved to use the measurements as a ballpark estimate and then found the perfect location through trial and error. It was a long and tedious process, but we eventually found the correct spots to drill and place the rotating component of the project. We continued working until the last minute in pursuit of a more aesthetically pleasing and multi-purpose design.
As we put the finishing touches on our project, it came time to prepare for the Madison Exchange. We made our plans to meet up and transport the project to HHS and adjourned having completed our project. After showcasing the design to our professors and peers, we started our project and made plans to consolidate our pictures and videos for the digital story. Overall, this project has taught us a lot about using tools, working as a team, and what home improvement store you should not visit.
Well, he never comes to the museum anyway, so it doesn't matter.
90% of our things.
Throughout this process, especially near the end, we became closer and truly worked as a team.
Were we to do this project again, we are confident that, with the knowledge that we have gained, we could create a higher quality product in a shorter time.
Is this the video? There's no, I thought there was like scripting.
What?
I thought there was a script.
No, that's not how this works. So
No,
like,
this is just like basically
What kind of shit is that?
filming us and then
That's it.
right.